Gas chromatography is a chromatographic technique used for the separation of volatile compounds. GC is a separation technique in which volatile and heat-stable solutes migrate through columns containing stationary phases at a speed that depends on their distribution ratio. The stationary phases, packed in the inner wall of the column, the stationary phase is made up of silicon grease or wax which can withstand a high temperature. The mobile phase used is usually an inert gas like helium or unreactive gas such as nitrogen. The mobile phase gas is kept in a cylinder, which is connected with the column via moleculars of the molecular sieve, separates the unwanted hydrocarbons, oxygen, and water, vapors that may interfere with the test sample during analysis. At the end of the column there is a detector which detects the sample. A gas chromatograph is composed of various components in a special frame. The components of the GC instrument include an injector, column, and detector, which are connected to a thermostatically controlled oven that makes the column able to reach a certain temperature. Two types of columns used in GC pack: column where the stationary phase is coated directly in the column, and capillary column where the stationary phase is coated with the inner wall. The column the mixture separation is based on differential partitioning of the components between the mobile and stationary phases. The component which has less affinity to the stationary phase, consequently less interaction. The moving phase in GC is a gas helium, hydrogen, or nitrogen that is available in the market with a very high purity. The carrier gas must be free from all hydrocarbons, water vapor, or oxygen, because all of these will damage the polar stationary phase or reduce its sensitivity. Because of this reason, the carrier gas system includes a filter that contains a molecular sieve to remove water and as an agent to reduce other impurities. Carrier gases do not have a significant effect on the value of the partition coefficient K due to the lack of interaction between the gas motion phase and the solutes to be separated. Gases that have low molecular weight have higher conductivity. If there is a compound that is carried by phase motion into the detector, because the BM of the compound is usually high, the conductivity will decrease inside the TCD detector. This filament is energized to heat it. These two filaments are connected by an electrical circuit called a Wheatstone bridge to balance the electric current. When the effluent contains analyte or other chemical compounds entering the detector, then the effluent will lower the heat conductivity. As a result, the filament becomes hotter, the temperature becomes higher, which causes the resistance to rise, thus lowering the electric current. Basically, organic compounds, when burned, will decompose into simple fractions with a positive charge, usually consisting of one carbon, C***. This fraction increases the conductivity around the flame, the place where the electrode has been installed, and this increase in conductivity can be easily measured and recorded. Electron capture detector equals ECD, equipped with a radioactive source, namely tritium or Ni, which is placed between two electrodes. The basic work of this detector is electron capture by a compound that has an affinity for free electrons, which is a compound that has electronegative elements. TCD detector is considered as an excellent detector for such analysis when the analyte contains halogen atoms or nitro groups. The use of the active element of alkali metal salt is as a source of ions in the plasma that is responsible for suppressing the ionization of hydrocarbons in the plasma. But on the contrary, the ionization efficiency of an MP by the thermoionic source is also helped by suppressing the flow of Hz and O2 air as plasma fuel. Increases the ionization of samples containing an ORP. Phosphorus and sulfur emissions can be isolated with a narrow tape filter and detected with a photomultiplier tube. This filter is placed between the flame and PMI.
In gas chromatography, data processing is carried out by a data processing device, data processor, or computer. The information obtained can be used in qualitative analysis, usually by comparing time, sample retention in the same analysis conditions. Meanwhile, for quantitative analysis, it is usually done with a relatively high calculation or a sample chromatogram peak area through the external standard method, external standard or standard in internal standard. Derivatization is a chemical process to change a compound into another compound that has suitable properties for analysis using gas chromatography. The reason for the derivatization: 1. To increase the detection limit and chromatogram shape. 2. Increase the volatility of non-volatile compounds. Non-volatile closing parenthesis. 3. Increase stability.